Good day. You're welcome to another edition of our daily maths videos. So this is a particular problem in the senior secondary category. In this particular problem, we have to find x in this equation. Take a moment to pause the video and try it out, and then replay to see your solution. Also, before we proceed, do not forget to like and subscribe to our videos, and also turn on your notification button to be updated on the latest videos we'll be posting. Okay, so let's proceed. In this problem, we have to solve for x. Now, the trick here is we're having 2x plus x, which will give us like a 3x. If you solve it this way, you'll be wrong. This problem, you see, this is the reason why mathematics always has a foundation where you, of course, you apply the foundations to solve complex problems. So in this case, I will apply the rule of Bodman's, meaning I have to multiply before I add. This bracket means it's a multiplication here. So there's no way I can add it to be 3x. So with that, I'm actually going to bring this over to the left-hand side by saying x squared minus 2x equals to x, open bracket, cube root of x minus 2. Okay. So we've overcome the first trick. The first trick was do not add it to be 3x. Obey the rule of Bodman's by multiplying before you add. So now you can see there's nothing to add. I have my left-hand side and my right-hand side. All right, so what makes this equation confusing is because we have lots of x's. There are x's at the left-hand side, there are x's at the right-hand side. But I'll start by isolating x for the prime element. This one is the one that is so obvious. So I can isolate x by dividing both sides by x. Okay, so we'll see what this does. Dividing both sides by x, we'll see what this does. Meaning the left hand side will be x squared minus 2x divided by x equals x, open bracket, cube root of x minus 2 all over x. Okay, so this makes this x to go away, and kind of the right hand side has been simplified. But at this left hand side, I have an x squared minus 2x at the numerator position, then at the denominator I also still have an x. So what I'll do is to factorize while I keep the right hand side the way it is. So follow. So in factorizing this, I'll bring out an x, open bracket x times x squared, minus 2, x times 2, 2x. So all over x. Now, let's see if that goes. X squared minus 2x all over x. So you see, while the right hand side becomes, if we have cube root of 9, for example, it simply means 9 raised to power 1 over 3. If we have cube root of 8, it simply means 8 raised to power 1 over 3. The same way if we have square root of 4, it means 4 raised to power half. So square root means half, cube root means 1 over 3. So, with that knowledge, I'm going to put this to be x minus 2 all raised to power 1 over 3. Okay, so I've kind of changed it to a power form. Took away the umbrella, made it a power form, 1 over 3 raised to power 1 over 3. So with that, my x can annihilate my x. I'm just having x minus 2 equals to x minus 2 all raised to power 1 over 3. Remember, this raised to power 1 over 3 means cube root of x. So what I'll do next, in order to create an identity for the left hand side, I will divide both sides by x minus 2 raised to power 1 over 3. So we say x minus 2 raised to power 1 over 3 all over x minus 2 raised to power 1 over 3. So this cancels out for us to have 1. Now take note of something. For those of you that are very good with logarithmic equation, if you can actually go back to check our previous videos on logarithms. So I can have a common base of x minus 2. Why? Because this x minus 2 is raised to the power of 1. Anything raised to the power of 1 still maintains that same thing. So this is raised to the power of 1. So I'm having x minus 2 raised to the power of 1. Since we're having like base for x minus 2, we have a common x minus 2. So what happens at the power? A division means a subtraction at the exponent position. So x minus 2 raised to the power of 1 minus 1 over 3. Why? At the exponential position, division will become minus with a common base of x minus 2. Equal to what? Equal to 1. Why? Because 1 over 1 is 1, 2 over 2 is 2, so the same thing over the same thing is the same thing, which is 1, 1. So this cancelled out to be 1. So now, simplifying the left hand side, I'll be having x minus 2 raised to the power 3 times 1, 3, minus 1, 2 over 3. So x minus 2 raised to the power 2 over 3 equals to 1. Okay? So in order to annihilate this exponential 2 over 3, I'm going to multiply both exponent by the opposite of the 2 over 3, which is 3 over 2. So let's do that. X minus 2 raised to the power 2 over 3 times 3 over 2 equals to 1 raised to the power 3 over 2. As you can see, this exponent cancels this exponent. So we are just left with x minus 2 equals to, this means the cube root of 1, then square all. That's what it means. Something raised to the power 3 over 2 means cube root of that thing, then square. Example. 8 raised to the power 2 over 3, over 3, 8 raised to the power 3 over 2 means cube root of 8. And what's cube root of 8? It is 2. So 2 square, it is 4. So an 8 raised to the power 3 over 2 is a 4. So in that same manner, what will be the cube root of 1? It will still be 1. If I square 1, it will still be 1. So x minus 2 equals to 1. Alright? CLT, collect like terms. X equals to 1 plus 2. X equals to 3. And that is the solution to our problem. And we've gotten the value of x. I can quickly go through our work. The first thing we did was to move 2x to the left, giving us x squared minus 2x. Why? We had to obey BODMAS first, which is multiplying before you add. And so when we moved the 2x to the left, we're left with just a multiplication problem. So with this, we had to divide both sides by x in order for us to annihilate this x, exposing cube root of x minus 2. Next step, we had to factorize and changing cube root of x minus 2 into an x minus 2 raised to the power 1 over 3. Why? Because a cube root means a raised to the power 1 over 3. So when the x cancelled in our factored form, we had x minus 2 raised to the power 1. It will still be the same thing as x minus 2. So we then had like basis when we divided both sides by x minus 2 raised to the power 1 over 3, making all of the right hand side to be annihilated to produce a 1 as the value at the right hand side, while the left gives us the common base of x minus 2 with the 1 minus 1 over 3. A division will become a minus for an exponential math. So x minus 2 raised to the power 1 minus 1 over 3 equals to 1 because all of this cancellation was 1. So x minus 2 raised to the power 2 over 3 equals to 1. So in order to annihilate this 2 over 3, we multiply by 3 over 2 at the top, at the exponential. So x minus 2 raised to the power 2 over 3, when multiplied by 3 over 2 at the exponential position, it will all cancel out to be 1. And so since we are doing the same thing at the right hand side, so 1 raised to the power 3 over 2 as well. And we know the cube root of 1 is 1. Square it will still be 1. So x minus 2 equals to 1. When we collected like terms, x is 3. So what do you need to master in order to be able to solve this type of problem? Is to see the trick hidden in the problem, which is 1, obeying BODMAS rule. 2, mastering the concept of indices and logarithm. Alright, so do well to like our videos and then see you in our next video. Thanks for watching.